Thank you very much. Good afternoon, everyone. Thank you for coming along at 4 o'clock. I know it's been a long day. I'm David. I work with companies across Australia and New Zealand to identify and mitigate bot threats. And today I'm going to be talking to you about the strategies that I use to do just this. This is very much a conceptual talk. I'm not going to be talking about the implementation details because the details remain the same across many implementation providers. But really what I want you to understand is the concept. So we'll be talking about this at a relatively high level. First off, of course, thank you to our sponsors who made today possible. It's been a good day so far, and I'm sure that tomorrow will be just as good. Now, first up, let's get some terminology. What is a bot? In the context of this conversation or this presentation, you have your website. So this is your standard web application, web server, static web content that is being accessed over HTTP by, firstly, your legitimate users. These are the ones that you want accessing your website, the human beings. Equally, bots. So these are bots that are sending HTTP traffic to your website. Now, bots can be one of two things. Bots can be good bots. So there are bots out there that bring value to your business. They aren't threats to your business. You want them to be using your site, to be accessing your site. Common ones are search engine bots. So these are bots that scrape your website, they crawl your website, and use that data to enhance your searchability, bring customers to your website. Archivers, equally, take the site, the history of your site and make it available in the future for historical reasons. And monitoring as well. If you're running a web application, you want a bot to automatically communicate with your website to make sure that it's up and running so that you can respond. These are all good bots. You like these. Bad bots, on the other hand, are what we really care about. These are things that are threats, and these are causing damage to your company. So scraping is a common one. You're running a pricing website. You crawl through, or you have someone writes a bot to crawl through, grab all the pricing, aggregate it. You may not be too happy about that. Scalping is a common, popular one. So people will go and write bots that go and grab all the tickets to a popular concert and sell them on the grey market and take that extra value and annoy all the fans. And fraud is one that we are seeing more and more of across Australia and New Zealand. This is actually causing quite a lot of damage financially, where you have attacks where, like credential stuffing, someone will take username and passwords off the dark web, iterate through them using a bot on your website, get access to users' account and use that for some sort of financial gain. And that financial gain can be quite material. And it's starting to become quite organised at scale. And so this is the one that many people sit up and start paying attention to when it affects them. One key takeaway is that good bots and bad bots is a continuum, and it's a continuum for every business. So if you're a business, your definition of a good bot is going to differ from another business. And the reason for that is that you've got different business priorities. So for example, I have one customer who came and said, I don't care if someone buys all the inventory off of my website and takes it from someone else because I make more revenue. Now, that's a good bot for them, but a bad bot for someone else. And this makes a silver bullet, we want to stop bots, very difficult. So you will have to decide where on this continuum you are and how you build a threat model around it. Equally, your evasion and mitigation techniques is going to differ from simple through to sophisticated. And this is where it becomes a real arms race in terms of how far you go and how far your threat actor goes in terms of building evasions to your mitigations for bot threats. And so as you go from simple through to sophisticated, it actually gets more expensive for both you and the threat actor. You can build very simple rules to stop simple bots. These are very simple, as it says, and cost-effective, through to the other end of the scale, which someone's going to spend a lot of money to work around those mitigations. And so from a threat perspective, there's a bit of an arms race about how much time you spend. As we go through these strategies, we're going to be working through from simple through to sophisticated. In terms of the architecture that we take today, our bots and our legitimate users are going to be communicating through a layer 7 firewall through to your web application. This is some box somewhere that is making decisions as to whether it's a bot and taking an action, whether it's blocking or allowing the traffic. And this is where the strategies will apply. So this is where you would apply the strategies in your infrastructure to protect your web application. So first up, strategy 0, easily identifiable bots. So these are bots like automated browsers. Curl, for example, on the command line will identify it by a user agent. Equally, automated browsers will commonly identify them in some way. Or search engine bots, for example, and other sort of legitimate bots will easily identify themselves as Googlebot or whatever it is that is using your website. And this is identified by, as I said, user agent. So the HTTP request will have a user agent that identifies that bot, an IP address that is shared publicly that you know is that particular bot, or robots.txt, which is a text file that you put on your server to say this is who can crawl my site and what they can do. Obviously, these are all very simple things, but they're easy to work around. So these are going to stop some of the more simple bots. It's going to stop perhaps, a simple, someone writing a curl script on their computer to iterate through your website. But obviously, the next step that they're going to do is just change the user agent when they send that request, and now they've evaded your simple mitigation. This is it's very cost effective, but it's very easy to mitigate. And this is sort of where this arms race is. So this stops the simple stuff, but someone who's potentially targeting your website is going to work around it pretty quickly. The next step is, okay, we know that there are bad bots out there on the internet. And so there are a number of IP addresses that these bots act from. And there's two sources of traffic that you can use. There are publicly and privately available lists for IP reputation. So for example, we know this IP is the source of bot or malicious traffic, and you can very easily get that list, add it to your layer 7 firewall, look it up, block it. Easy, simple, cost-effective, stops some of the bad traffic. Equally, an anonymous IP list, so Tor exit nodes, proxy services, VPN services, you can aggregate that. Very simple to look up, very quick to block, stop some of that traffic. So that is, an easy way for those who are like, okay, I want to work around some of the legitimate mitigations that you've put in place. I'll start using a proxy service with an anonymous IP. So that's the next strategy that I use to stop this sort of the next layer of bot traffic. Strategy 2, slow them down. This is a very effective method, not just for managing bots, but also for denial of service. So for example, one IP address can send 10 requests per minute. And so this means that someone's writing a script on their computer will only be able to do 10 requests. So if they're trying to scrape, it's going to take a very long time to scrape down all the data on your website because I can only pull down 10 sites at once. So boom, I've made it more challenging for a bot threat actor to gain value from my site. Now this is where the bot threat actor is like, okay, this is actually more value. I'm going to spend some money to get the to work around this mitigation. And so I can go to one of the many botnets as a service on the internet, and for the price of $137 a month, get 30 million IP addresses from residential proxies that they can use to use 10 requests per minute to scrape your website. So this is how much of that someone is spending to work around your mitigation, but it's pretty effective, pretty easy. As you can see, you can send 25 gigs of bandwidth. That's a lot of HTTP requests. And so this becomes the next challenge that you need to work around. And this, as it says, $137 is a chunk of change, right? Someone's spending money on it, someone's running a botnet. So how do we work around that? Again, this is where we start to get the more complex, the more costly mitigations in place. So strategy 3. I've got a botnet, I've got 30 million IP addresses sitting on a residential network. So typically this might be someone that has an IoT device that's been taken under control of a botnet operator and is now using it as part of this proxy service. Is that I make them do some work. Before they can talk to my website, I make them do two things. So the first is they have to be able to run JavaScript. So no longer can they just run a curl script, set the user agent, and off they go. They actually have to spin up a browser. This, for an IoT device that's been hacked that's sitting on a residential proxy network is a much bigger ask. It's costing a bot operator more because they have to get a bigger piece of infrastructure to run it. Equally, as second to that is that not only do we make it run JavaScript, let's make it do some actual work. Let's make it do proof of work, a bit like Bitcoin mining, that generates a hash or some kind of, computationally expensive exercise that it must complete before it gets permitted to access your website. And so again, if you've got a bot operator, it's going to take longer for them to access your website. They have to do some work. For a bot operator, it costs them money. For your legitimate users, it's just something that kind of happens behind the scenes as they're accessing your website. In exchange for that proof of work, you get a token as well. And this token is in the form of an HTTP cookie, and that brings it up a level. From an HTTP request being entirely on a layer 7 layer, it's up to an HTTP session where you get a view of that HTTP session across a number of requests. And so that decouples it from the IP address, and because that can be challenging if someone's on a carrier-grade network, or on a home network with lots of devices. And so this brings it up a level. We use a session, an HTTP cookie, to identify that session, and then we can start to manage it more effectively. Strategy 4. Okay, so that person is fine. They've got a piece of something running JavaScript. They've got it running some browser on a bot somewhere out there on the internet. We can do a fingerprint. So that JavaScript, as it's running that proof of work, can also take a fingerprint of the browser environment and see, is there anything here that doesn't look usual? Is it running some special automation tool? Is there something funky about how it's running? Can we apply some heuristics around that signature to fingerprint it and identify whether it's a bot or not? Again, this isn't perfect. People will build mitigations. That's fine. But it just increases the cost. You've got to spend time. Your threat actor now needs to spend time, avoiding this fingerprinting thing. Makes it a bit harder. So that's another one of the strategies that I use for the next layer of sort of threat actor that grows in sophistication. Strategy 5, capture ? So captures are controversial for everyone. They're controversial for you as users because they're a real pain to fill out. You sometimes question if you're a replicant or not when you don't get it right. And they're also a pain, when I'm dealing with people who are building a product, is that they are worried about, from a user journey perspective, that your users don't want to fill it out, so you don't complete your shopping cart and you leave and you abandon it and you've lost that sale. So people who are selling a product don't like them either because of the abandonment. One thing, and I do want to say though, as well, is, they are still effective. They do add a layer of, protection, and so they can be useful in some circumstances. But I struggle to say whether they're universally applicable. So on the right here, this is a TikTok video that I found of a professional captcha solver. So if you go to YouTube now, you can find a job solving captchas. You'll make a few dollars an hour. It will pop up a screen that looks like this, and you go da-da-da-da, da-da-da-da, da-da-da-da. You solve captchas that get put up for you by bots. Results get sent back. That token gets sent. That bot actor has completed that captcha. So for a few dollars an hour, someone can work around your captchas. But again, someone has to pay a few dollars an hour. Is your site worth spending a few dollars an hour to access? Equally, large language models that exist out there, you give a captcha to a large language model, it will, in certain circumstances, solve it. It still costs money, probably less than a human. So captcha can be useful, ? Consider it. It can be in certain circumstances, but I probably wouldn't use it as a universal mitigation for these reasons. Payload analysis. This is the next step where it gets a bit trickier. So when someone sends a submission to your site to create a new account or sign up for something or use a username and password to log in, is that you get that payload. Username, password, address, JSON payload. There are a number of things that you can now do with that payload to start to see, is someone running a botnet on it? So for example, is someone traversing basically passwords, trying to brute force a username and password to gain access to someone's account? So basically, you keep track of a username. Are we seeing that same username is being iterated through with passwords, as being brute forced. Equally, someone might be iterating through addresses to gain something. Are they doing some sort of iteration on that? And remember when I said about that token? If someone's sharing that token across multiple sites because they solved that captcha once with their captcha farm people, you can now kind of tie that all together and see that same person is enumerating through all of these username and tokens across multiple IP addresses. So you can start to build these sort of complex heuristics around the session level metrics, but also are they traversing across payload data? Compromised credentials is another one. So as I said at the start, credential stuffing is a common attack vector for threat actors to log into accounts and gain some monetary value. And in some instances, that can be quite significant. And so when the username and password comes through, your layer 7 firewall, your identity provider will look at it, look at the username, look at the password. Has this been compromised? Is this on the dark net? Has this been leaked? If it is, then we want to flag that. We want to block that request. Maybe we want to tell the user they need to reset the password, whatever it might be. So that's another example in field use, as I kind of alluded to previously, is if someone is reusing the same field across multiple attempts, even multiple IP addresses, that could be an indication that they've written a bot and they're just enumerating through other values. So payload analysis, again, it is more expensive for you because now you need to manage the state of a whole lot of HTTP requests. But it is also more expensive for your threat actor. They have to make sure that they're now getting value from this. Strategy 7, machine learning. This is where it gets trickier again. And there are two approaches that you can take to this. So first is user interactivity. So remember that JavaScript that I was talking about before that takes a fingerprint of the browser, does some work? That's still running in the background. You can use that same JavaScript to say, oh, this person is typing this way, this moving their mouse, and many sites that you go to now will be doing this. I know some of the banks have got your acceptance when you log in to their app now, is that basically you use those heuristics to apply a machine learning model to see, is this a legitimate user or an illegitimate user? So that's one metric that you can use, or one model. Equally, token requests. So now that you've got this HTTP session that you can see, this represents a user in their browser at the HTTP session level. You can track those requests, you can build a model and see this is what legitimate users look like versus bots and manage it from there. There's two kind of ways that you can do that. You could look at the trailing 5 minutes. So for example, you could build, these are the HTTP requests over the last 5 minutes. This is what we see as legitimate users. And then if something sort of from an ML model starts to look outside of that, then that's when you can apply your heuristics to block that traffic. Equally coordinated activity. If you've got 10,000, 30 million IPs, 30 million bots that are acting on the behalf of someone, is that you can apply heuristics to sort of aggregate commonality across those requests and see, is someone using coordinated botnet to target your website? So it's looking at it at a next level. Is there commonality between a whole lot of requests that are all coming in at the same time that start to look a bit similar and a bit suspicious? Now, machine learning models will be wrong. Everyone, of course, has used a large language model and it's hallucinated a wrong response. That's the nature of machine learning in general. Now, basically, this will give you a score between 0 and 1. 0 is not a bot, 1 is a bot. You might get in the middle that you're not quite sure. In this case, to my point around captcha question mark, rather than blocking it, is that you may want to just force a captcha periodically. That way it stops a bot farmer who's basically got something running all the time to something that just happens periodically that they can't predict, so it becomes harder for them to automate. So for machine learning, when you want to deal with those false positives where your legitimate users may be impacted because for whatever reason it's just triggered the machine learning model incorrectly, is that when you pop up the captcha or make something else happen to check their behavior in more detail. And many of you will see this as you traverse the internet. Sometimes you'll go to a site and you see the little spinning wheel pop up occasionally. And that's because for whatever reason, the machine learning model thinks that you're suspicious. Clearly you're not, but It's just the reality of being on the internet. This is my favorite, strategy 8, obfuscation. So again, remember this continuum, simple through to sophisticated for you and your threat actors. At some point, someone is going to keep spending more and more and more and more time mitigating. At the end of the day, they could just go and hire 100 students to go and click around your website and gather the data. It would cost them a lot of money, but that's just the reality. And so obfuscation is basically, okay, we will let them think they have won. And to do that, our legitimate users, when they request something from your site, they will get back a JSON payload normally that says product widget, for example, price is $9.99. They get back the actual data. But what you can do is, if your layer 7 firewall receives some traffic and it's like, hey, web application, I don't know, I'm pretty sure this is a bot, is you return to them a random price that looks right, $11.24. And this is used increasingly frequently, I might add, for customers who are just like, especially pricing sites, to make botnet operators think that they've got the right data, aggregate it, and then realize it's wrong several months later, potentially. So, price, just return a random site number adjusted by a random point. They think it's right, they go away, you're happy, everyone thinks they're happy. Of course, the bot threat actor is none the wiser. Again, equally, I've seen other sites where the images are valuable, as they'll just return random images. And so you introduce some randomness. You might make it right 90% of the time, even. The other 10% of the time it's wrong. And that just devalues all of the data that they're getting. So this is another strategy that you can apply really when you get to the more sophisticated end, where you're like, well, someone's going to get access to it. Let's just make their life really difficult and make the data that they get worthless in many instances. So this is basically the strategies that I use every day with my customers to help them identify and mitigate bot traffic, going through from the very simple ones down to the more complex. And the reason I do it in this order, and these kind of looks like the rules that I put in place to manage this traffic, is that these rules at this top are very simple, very cost-effective to implement. I don't have to have a big chunky server to detect this bot traffic, block it. Stop the easy stuff here before I get down to here with behavior analysis, because if I want to run an ML model against my millions of requests per second, I'm going to need a lot of infrastructure to do that, and that's going to get very pricey. So I basically build rules that stop the easy stuff, and it filters down so it becomes more cost-effective as we get through it. So the key that's really the key takeaway, is that there's no single fix. You'll have to work through this in terms of what the strategies apply to the threat actors. And I know there's been quite a lot of talk about threat modeling. So it's very useful in terms of using threat modeling to put these strategies together. And because it will differ for your company and how much effort you want to put into it. At the end of the day, someone wants the data, they probably will get it. Is how do you also mitigate that as well? So that's the presentation. I've got a QR code for feedback. I love feedback, so do send it through. And I know I've got a few minutes for questions, so I'm happy to answer.
Thanks. As someone who, gets a lot of CAPTCHAs because I browse the web using Tor and fingerprint resisting and stuff like that. Is that something that you're concerned about? Like, how can I make life easier for people that are genuinely interested in security and in privacy? Or is that just not something you care about at all?
Look, I mean, so personally, I work with customers. Oh, you got the microphone already. I personally work with customers to mitigate threats. And so they are taking a threat-based approach that someone is credential stuffing, potentially through Tor exit nodes or other things. And if they take a look at what's the impact and what's the likelihood, put a risk-based view on it, at the end of the day, they're a business, there's an impact to their business, which can be a material amount of money. And if there is a negative impact on a subset of legitimate users who are using Tor exit nodes, then that's just the cost of doing business. So that's the unfortunate reality of being on the internet today, is the illegitimate bot bot owners are making it more difficult, and businesses are making reasonable decisions on how to mitigate threats to their business. And to reiterate, these threats can be quite serious.
More questions?
Hi. My question is around the timeliness of identifying threats. I think like a lot of people here, I've seen the results of them afterwards. Your database is stuffed with fake users that all look the same. And at the time, perhaps, you might not be able to identify them because there's a pattern, but can you identify the pattern at the time? I guess the question is, firstly, with the bursty nature of these attacks, can you identify them at the time, and is there much value in identifying them after the fact?
Yeah, so, the timeliness, if we go back to in particular, like your ML model, right, is that does take time to train, and it does take time. But if you look at the training last 5 minutes, and, very quickly within potentially a minute, you can aggregate the results and see, okay, for this particular this IP address, we're seeing lots of signups, or we're seeing lots of signups with patterns that indicate that someone is automating it. They're enumerating through obvious addresses or something like that. So from an ML perspective, that really depends on your algorithm, but the inference of that ML algorithm can be very quick, seconds, minutes at worst. So that slows it down. But in terms of mitigation after the fact, really that's going to come down to a case-by-case basis, depending on what the impact is. In some instances, if we think it's a bot, what I've done with some customers, particularly like customers where signups are quite valuable, like it does take a long time to get someone to go through that journey, and you don't want them to drop out at the last minute and their request be blocked because you misinterpret them as a bot, is that this whole 0 through 1 is that you pass that, we think with a probability of 0.8 that it's a bot, we pass that request through to the back end, and then we put it on a queue for manual human review. So, everything under 0.5, that's cool. We will let that through automatically. That goes through. Everything above 0.5, that goes through to a separate queue, manual review. Again, that comes down to what is the threat's impact on your business and how much is it going to cost for you in terms of someone doing that manual review. So, I do see that a bit in sort of the fintech type space where they don't want to lose that sign up. So they do spend a bit of money hiring people to do those manual reviews as to whether it's legitimate or not. Equally, relying on identity services as well can be quite valuable to validate someone has a legitimate identity.
So on the lower side of strategy, around strategy 0, 1, 2, something I see often a lot is bots spamming things that don't exist on your system at all, like file extensions, admin portals, things like that. And so I set up rules like that to block bots that are just coming in with parts I don't care about. Do you see value in that kind of stuff at that lower strategy, or do you find that gets outdated really quickly and then get into more trouble than?
That's sort of a traditional web application firewall domain where there are known vulnerabilities out there. Let's add some rules to sort of stop that traffic. So certainly it generally will be bots, but I kind of put that separate as traditional application vulnerability defense. And I think that is valuable from a defense and depth perspective, but the impact of that is typically like a shell gets popped on your site and someone attacks it. This is more attacking your business processes than your applications.
One more.
Thank you. Amazing talk. Just a funny question. In your personal opinion, if you were in charge of security of an organization, returning to the chart, good, bad, bot, where would you place bots like Shodan, Census that gather publicly available information from your website, and then, for example, and then run it against CV engines or just open databases of technologies that's used. You know what Shodan is, right? Sorry, I explained it very poorly, but hope you get the question.
Yeah, look, I think that really depends. Like, if you take a threat-based approach, what is the threat to your business? You know, is it going to take someone very long to run that manually against your website versus an aggregated thing? And so I think that's just a business threat decision. And that will differ for every business. One common thing that I get like very commonly at the moment is AI bots. So AI bots will, and they are becoming increasingly aggressive, will aggressively crawl your website to pull all the data down to train the AI models. In some instances, they're a bit gray in terms of how they respect robots.txt, and talk to me after if you want some additional details on that, because it's a bit annoying at the moment, to be honest. And that can be a bit of a business decision, because some businesses have policies where we don't want our data to be used in large language models. And so people will obviously want to block those, and so they will put in place mitigations explicitly for that, versus others, they're like, oh yeah, that's fine, whatever it ends up on a chatbot, that's fine, it's probably good for our business. So it again comes back to being a business decision to what the impact is on your business.
Right, we are out of time, unfortunately. Thanks again.
Thank you. Thank you.